Module 4, Engine Systems and Operations. Module Overview. The engine is often referred to as the heart of the automobile because it converts fuel into mechanical energy, powering the vehicle and enabling movement. Module 4 of Automobile Mechanics focuses on a comprehensive study of engine systems, operations, components, classifications, and diagnostics. Understanding engine systems is critical because they determine not only the performance of a vehicle, but also its fuel efficiency, environmental impact, and long-term reliability. 1. Fundamentals of engine operation. At the core of every internal combustion engine, ICE, is the principle of energy conversion. Fuel contains chemical energy, and through combustion, it is transformed into thermal energy. This heat energy expands gases within the engine's cylinder, driving pistons downward and producing mechanical energy. This mechanical energy is transferred through the crankshaft to ultimately drive the wheels. Key thermodynamic principle. Most engines operate on the Otto cycle, petrol engines, or diesel cycle, diesel engines. These cycles involve the intake, compression, combustion power, and exhaust processes, all governed by the laws of thermodynamics. Four-stroke process. Intake stroke. Air-fuel mixture, or air in diesel engines, enters the cylinder. Compression stroke. The piston compresses the mixture, raising temperature and pressure. 2. Types and classifications of engines. Engines can be classified based on fuel type, ignition method, configuration, cylinder arrangement, and cooling system. By fuel type, petrol, gasoline, engines, diesel engines, alternative fuel engines, CNG, LPG, biofuel, hydrogen, etc., hybrid and electric drive engines in transitional technologies. By cylinder arrangement, inline, I4, I6, V-type, V6, V8, V12, flat boxer, used by Subaru, Porsche, W-type, rare, found in luxury cars like Bugatti. By cooling system, air-cooled engines, simpler, used in motorbikes, older VW Beetles. Water-cooled engines, common in modern automobiles. By ignition, spark ignition, SI, petrol engines, compression ignition, CI, diesel engines. 3. Major components of the engine system. An engine is made up of multiple subsystems working in harmony. Cylinder block, the main housing of the engine containing cylinders, coolant passages, and oil galleries. Cylinder head, houses valves, spark plugs in SI engines, injectors in CI engines, and combustion chambers. Piston, moves up and down within the cylinder, transmitting force to the crankshaft. Connecting, rod, links piston to crankshaft. Crankshaft, converts reciprocating piston motion into rotary motion. Camshaft, controls valve timing for intake and exhaust. Valves, intake valves admit air/fuel mixture. Exhaust valves release burnt gases. Flywheel, maintains engine momentum and smooths out power delivery. Lubrication system, oil pump, sump, oil galleries for friction reduction. Cooling system, radiator, water pump, thermostat, coolant channels to maintain optimal temperature. 4. Fuel and air systems. The combustion process relies heavily on a precise air-fuel ratio. Fuel delivery systems, carburetors, older vehicles, mixes fuel and air mechanically. Fuel injection systems, modern vehicles, multi-point fuel injection, MPFI, direct injection, GDI for petrol, CRDI for diesel. Air intake system includes air filters, throttle body, intake manifold, and turbo/superchargers in advanced systems. 5. Ignition systems. Conventional ignition, mechanical distributor systems with breaker points. Electronic ignition, sensors and ECU, engine control unit, controlled, more precise. Diesel ignition, relies on high compression, no spark plugs. 6. Exhaust and emission control. Exhaust gases must be expelled efficiently and treated to reduce pollution. Modern vehicles include Catalytic converters reduce COHC NOx. Oxygen sensors for ECU feedback. Exhaust gas recirculation EGR systems. 7. Engine performance and efficiency. Several factors affect efficiency: compression ratio, ignition timing, air-fuel mixture, valve timing, VVT systems, maintenance, clean filters, proper lubrication, cooling efficiency.